All right, so the last one I'm going to do a video solution of because it's Sunday night and it's time for me to chill out, cook some dinner. But the last one is this number 5, and I wanted us to go through a pseudo-chiral center thing together because this is one of the newer concepts we covered in this class. And really what this means is you have to designate these small letters R and S to a particular molecule. Now the definition of these molecules that have pseudo-chiral centers are that they are a meso molecule. We talked about that they're going to be a meso compound. As soon as we know they're meso compounds, we know they have to be achiral. But I'm going to come back to that because this problem was only worth a point. Initially, I was going to have it be worth 1.5 points, but I lowered it a little bit. And I lowered the amount, like this answer, to just 0.5 point because actually a lot of you got it wrong. You were telling me this was a molecule that was chiral, and I was surprised by that. So let's talk about it. What I wanted you to do is figure out if this was R and S, that was R or S, and designate those. So we have R here and S here. It means this guy here is little r. Alright, so you can go through and figure out how that works. This is an example right from your textbook on the definition of pseudo-chiral centers, so you can look that up. The thing is, it's meso. I mean, if I had just given you this and asked if it was meso and hadn't talked about pseudo-chirality and this little letter R, you would have said, sure, meso compound. There's my plane of symmetry. Yep, got it. It's all good. As soon as you say meso, it's achiral. That's all meso compounds are achiral. This is a meso compound that is still achiral, but it happens to have something called a pseudo-chiral center. This doesn't make the molecule chiral. And I think that's where the confusion came in. This is present in meso molecules, which are still achiral, and it's a special scenario where you can have the molecule right here where this is going away from you. You can draw its mirror image. These are the same, right? These are not a pair of enantiomers, so it's not chiral. These are the same molecule. They're meso, right? Still little letter R at that chiral center. But there exists another molecule where this is coming out at you. This pair of compounds exists where that is the R designation there, and this one's the S designation here. This exists as a different set of molecules. These aren't mirror images, right? This is a meso compound. This is another unique meso compound, but both are achiral. Some of you were telling me that this and this were mirror images and weren't superimposable, so therefore were chiral molecules. You were coming to the solution of it being chiral by talking about this other molecule, the S, that exists. Well, they both exist, and we have this designation for them so we can talk about molecule R and molecule S, but they still are both meso, and they still are both achiral. They happen to contain a carbon like so, right, that we define now with this our new term as a pseudo-chiral center. I hope that helps on that one. So this molecule and its mirror image, right, the molecule and its mirror image are the same molecule. They are superimposable. So that's another way we could know that it's achiral or not chiral, unchiral, non-chiral. This and this are not mirror images of each other. They're two unique molecules. All right, I think I've said that enough, I hope. Think about it. All right, good night.